So in our test one, they have a few questions. I just almost completed the design before I came here for the class. And there's one question about I give you the block diagram and asking you to simplify and to find the transfer function for the output input. Okay. So those things, because our test only have 1 hour in classroom, so you shouldn't expect very complicated system. So basically, only is on the fundamental concept. And again, the two systems are equivalent, and you might give a try. Okay. And this is a little bit becoming a little bit more complicated systems, but shouldn't be hard. This is a single loop, and this is a three-way. So basically, you can combine the G3, G4, and minus G2. So these are a little bit. I doubt these have the mistake in the answer. We can try this one, see happen. Okay. So for this one, this system, let me draw the block diagrams and simplify. This is G1 here, and this is the plus, minus, and I just copy from the information. So this is our R1. And this one, basically here, we have a feedback here. Feedback is a multiplication of the three games, G3, G4, and G2. However, G2 is minus. I put a minus here. So this is our output, C1. So for this case, we can calculate basically C1 equal to G1. Let me write it up here. So C1 equal to G1 multiply with E. The signal here is E. What is E? E equal to R1 minus this signal. Okay, that signal equal to minus G3, G4, G2 times C1. So here minus minus, that should be plus. So that's the G1, R1 plus G2, G3, G4, C1. Oh, I think that is right. Okay, that's okay. So I think in this way, C1, you can work on R1 should be equal to this. Okay, my mistake. My mistake. Because usually I expect, never mind. So again, the four four systems are equivalent. No, they are not equivalent. So from here, we simply exercise. For those ABCD, the four systems, they have the same, the transfer functions are different, but they have the same denominators, which means they have the same characteristic equations. And somehow, in the arrangement, the numerator is a bit different from one from another. Those are from our textbook, and if you have time to refer to them, I think that should be the figure numbers in our textbook. Okay, so I'm improving. So in the next sections, I have the handouts printed already, so I will take that to you. Okay, we can move on to the next slide. We good? I can wait for a few more seconds. Good. So here we exercise this one. Let me pull that down a little bit here. So this one is a little bit more complicated. So here we have three loops. Okay, and here we have the two feedback loops and then three feedback loops. So this is the method suggested by the authors of our textbook. I don't want to follow, I don't want to spend my time to read the content to follow this one, because I think I can do it by very just intuitive way. I believe everyone should be able to do it. Now, want to try this one as well? You want me to try? Oh, okay. So now for this one, you see C is equal to, basically at this point, this is C. Okay, so C equal to G3. G3 and multiply with the signal, okay? And the whole signal is here. So G3 multiply with this signal is G2 multiplied with this one, so G2. And with this one, let me call this one is E1. How about that? Okay, we make a first symbol here. So what is E1? And E1 equal to, yeah, we can make a scratch labels. So this is alpha beta. Okay, so E1 basically equal to alpha minus beta. And that is for our scratch notation. So G3 and G2. And what is alpha? Alpha is equal to G1 and multiply with this one, let me call it E2. Okay, and then we work on the beta. And what is beta? Beta equal to H2 times C. Okay, so basically it's C. So now at this moment, we take a break. So from here, this is our scratch calculations. So from here, we can see we have C both ends appeared. So that means C and 1 plus G3, G2, H2 equal to G3, G2, G1 times E2. So this is a relation between C and E2. Okay, so that is our scratch notations. So and then we can continue here. So what is E2? Because if I would keep deriving the E2 to something, I'm going to write a lot. So I'm going to stop here and then I have to start with the new things. So E2 here will be equal to, let me call this is E3, and let me call this is gamma. Okay. So E2 equal to E3 minus plus gamma. Okay, and what is E3? And E3 equal to R minus this one. E3 equal to R minus this. What is this? That is C. Okay, so that is E3. And what is gamma? Gamma equal to the output of H1 times the signal here. I didn't put a symbol here. So what is this one? This signal equal to C equal to C3 times signal. So this signal equal to C divided by G3. How about this? Be good? Any mistake here? Shouldn't have. Okay. Shouldn't have. So now we do it. So from here, let me simplify this one. So this is R plus C and minus 1 plus H3 H1 G3. Okay, I simplified these things. Will be good? So that is E2. Okay, so E2. So the E2 have containing R and C, and also here we have these relations. From this relation, we can plug in what is E2. E2 basically equal to C times 1 plus G3, G2, H2, G3, G2, G1. So this is multiplied with C. You good? So right now, successfully, we're looking at these relations. For these equations, on the both side, only appear is R and C. That is the information we're looking for. So after arrangement, allow me to stop here, then we should be able to find the relation between C over R equal to something. Be good? Okay, so that is my suggestions. And here I said demonstration on whiteboard. So we should have the result, and that one should be equal to this one. Okay, if you implement the C over R one more time, then you should get the result. Okay, so this is our textbook example here. The textbook should have the answers as well, but you can double check with my calculation. That should be right. I've been working with everyone here. Okay. I think this page is continued from the previous page. And this one basically is the textbook solutions, and that should be the result. Okay, that should be the result here. You can refer to the. This one, I prefer not to do the demonstrations, but providing for your exercise. So the reason why I copy in this way, because I try to include everything in a single line. So basically that is the stepwise from provided by our textbook. But again, if you have learned the way I show you kind of tier-wise moving on, you don't need to follow it. You can try is this, you can try is to compare your calculation with the answers. Good, okay. Those one will be good for homework exercise, but won't be good for our 1 hour test, okay. So here they summarize, and we have learned, hopefully, how to do the transfer function. If this is the output, this is the input. So say if this is a numerator polynomial, this is the denominator polynomial. Okay, and we know that here is the, for ds equal to 0, and that is called the characteristic equations. And the roots of the characteristic equations, or the root of the ds, is called the poles. Okay, so the poles is the root of the ds equal to 0. And as numerator is equal to 0, the root is equal to 0. Okay, and the system dynamics, how quickly it's going to oscillate, and how badly the oscillation magnitude of the oscillation will be, that really will depend on the poles. The poles are the sole information to determine the system dynamics. Zeros will be more or less determine the magnitude and statistics error, but most of the time in the first step of learning the controls, we will touch the poles. We will get more study on the poles first. Okay. So that is the quick summaries of this. So here the tables, and we continue this one we've seen before. So this one will be the good exercise. And transfer functions, and again here we might, so start from, we can have the new sections.